So what we're doing in this section is we're going to look at all of the different properties of logarithms, and some of these we've already learned, okay? So I'll have you fill some of these out, and I'll have you do some problems in class. First of all, this is the general definition of logarithm. We've already learned how to do this. I want you to write this example down. I'm just going to give you an example for each thing. So if you had something like, let's say we have logarithm base 3 of, say, something like 9 is equal to 2, then you can change that into an exponential form. So this is the logarithmic form. So this means the same thing as 3 to the second is equal to 9. Okay, that's what a log is it's an exponent. So one thing on there is the answer to a logarithm is an exponent. All right, and that's something that we talked about last week. We worked quite a bit in that written assignment 9. If you did that, there was probably several problems on there where I had you just change one form to another, okay? Right? Here's one additional example. If you had something more general, like if you had log base 10 of 7 equals z, then you would say 10 to the z is equal to 7, okay? This part right here is the base, and then this part right here is whatever it's equal to is the exponent. That's the way that goes. All right, so it's a matter of knowing how to change those numbers. Okay, the second property says that if you have a log of any base, that b represents any base of 1, you always get 0. Okay, so here's the reason why. So what I want you to write down is log base b of 1. And I taught you how to do this last week. If you're trying to figure out the answer to a logarithm, you just set it equal to x, okay? And then write this in exponential form. So in exponential form, we would say b to the x equals 1, okay? So let me ask a real simple question on this. What power do you raise b to get 1? In fact, what power do you raise anything to get 1? 0, okay? So that's why the answer on that's going to be equal to 0. Okay, so anytime you take a log of 1, you're going to get 0. So here's a couple other examples real quick. If you have log base 7 of 1, the answer is automatically 0 because 7 to the 0 is 1. Okay, even if you had something like ln of 1, that's equal to 0. Okay, because remember, ln is really a base e, and e to the 0 is 1. Okay, so that's how you know that. That's why you know that. Okay, next example, let me show you what this one is and why you know this. This one says if you have the structure log base b of the same base b to the x, that exponent is the answer. So here's the reason why. Go ahead and just write down what I have on here. Just write down log base b of b to the x. Just write that down only, okay? So what we've been doing on these is I've been telling you, if you're trying to do a log in your head, you set it equal to x, then write this in exponential form. If I write this in exponential form, I'm going to say b to the x power is equal to b to the x, okay? And what's going to happen on that is you're basically going to have the same thing automatically. X has to be equal to itself. So a more general example, and once you learn the property, it's easy to do, would be something like if you had, say you had log base 2 of 2 to the third. Now, according to this property, the answer is 3 automatically, okay? Here's one more example right now if you want to. If you had log base 8 of 8 to the 10th power, the answer is 10 automatically. Okay, what you have to do is you have to understand why that's the case, okay? So here's why it's the case. It's simple, really, when you get right down to it. If you write this in exponential form, you would say 2 to the third is equal to 2 to the third. Okay, I mean, that's how you write this in exponential form. This to the third power is equal to that. 8 to the 10th is 8 to the 10th. Okay, so that's why that property works the way it does. Okay? Okay, so before I move to this next thing here, let me just kind of quickly check you on a couple of things. I mean, there's nothing to it, but once you learn the property, but you have to know what the properties mean. What if I had log base 100? What is that? Log base of 100 of 1, what do you think the answer is? 0. Okay, which property is that? Property 2, right? Okay, all right. Here's one other one. What if you had log base 9 of 9 to the 1,000th power? What do you think that is? 1,000. See, that's property 3. Okay, so partially what we're kind of doing on this is learning to recognize the property, but the more you understand the property, more likely you are to remember it. Okay, because if you don't understand the property, you're going to forget this. Okay, so this one, basically, I'm going to give you an example on this property. This is another one that's pretty simple. Those of you who go on and take calculus, particularly like in calculus 2, this particular thing shows up all the time. So a lot of times, if I teach Calc 2 or something, I have to review this property because students have already forgotten it. So here's an example. If you had 7 and inside the exponent you had log base 7, the bases have to be the same of 10. The answer automatically is 10. So it has to have a certain structure to it. Okay, like if you had 12 and in the exponent you had log base 12 of 15, the answer is 15 automatically. That's what that property tells you. Okay, so the reason why on that goes this way. I'll show this. A lot of times students do not understand this, but write this down on your paper. Write down log base b of x is equal to log base b of x like that. Just write that down. You know that's true, right? Because I just wrote down the same thing twice. Now, how do you write this in exponential form? You say this thing to that power is equal to that thing. Okay? This to that power equals that. So if you write this thing in exponential form, it's going to go like this. You write down the base, this becomes the power, and then that's equal to x. That's where that thing comes from. Now, that sometimes is hard for students to see for some reason, but if you know how to write something in exponential form, you basically get that thing automatically. This to this power equals this. That's what I did. This to this power equals that. That's exponential form. Does that make any sense? Sometimes it is really hard for students to see, but you can get by when you're kind of learning this. Just know the property. And the property is easy. Okay, if you got any number and that exponent has the same base, then that is your answer automatically. Okay, that's what that's saying. Okay, all right. Now I'll go down to 5 and 6, and we're going to kind of work a lot on how to use these properties. So these right here, I'm just going to give you some calculator examples to prove this to you. So write this down. Let's just write down log of 7 times 2. According to this property, if you have a logarithm of a product that you're multiplying two numbers, 7 and 2, then it turns out that that's the same as log 7 plus log 2. That isn't going to prove anything to you, but it's going to demonstrate that it works, okay? And that's probably good enough at this level anyway. Right, get your calculator out if you have your calculator so I can show you a couple things on this. So one thing on your all's calculator is the log button is a base 10. The ln is a base e. We talked about that last time. So if you type this in like this, just type in log, your log button, and then 7 times 2, close parentheses, and get the answer. And you couldn't do that one in your head. I can't do that problem in my head. The only time you can do them in your head is if you get whole numbers and stuff. There's no way I could figure that out. Okay? Well, do this now. Do the log of 7, close parentheses, plus the log of 2, and see if you don't get the same answer. Okay? And see, that demonstrates to you that it at least works. Here's one other example to write down. Let's do ln. This time do something like 2 times 3 times 4. Okay? That would be the same as ln of 2 plus ln of 3 plus ln of 4. Okay, so it's just kind of good to do this on your calculator to see how it works. So if I do ln of 2 times 3 times 4, there's no way you could do that in your head. You just get a bunch of decimals. But if you did ln of 2 plus ln of 3, and then plus ln of 4, well, you get the same, whoops, put the wrong thing in there. You get the same answer, okay? Well, that just demonstrates that it works. It doesn't demonstrate why. I'm not going to go into that part, okay? Okay, property 6. We're going to do the same thing on our calculator with this. So I'll give you 2 examples to do on your calculator. So let's say that you were doing the log of a fraction. Say you were doing log of 10 thirds. Okay, we're going to do a log of a fraction. And again, let's just do that on the calculator. Okay, so I'm going to just type my log button and then do 10 divided by 3. And I get that answer. Okay, you get decimals. There's no way you're going to do this in your head. But what I'm trying to show you is if you have a log of a fraction, it turns out that it's the same as the log of the numerator minus the log of the denominator. Okay, so unlike the previous example where we broke it up into adding logs, well, we subtract logs. So just prove to yourself that it works on your calculator. We got log, you do log 10, subtract log 3. Okay, same answer. Okay, you guys see what I'm trying to show you there? Okay, do one with an ln, just pick something out. Let's say we had like the log of 8, the ln of 8 over 2. Okay, well, that would be the same as ln of 8 minus ln of 2. Okay, you get the same answer. So that's a good way to just demonstrate to students that that property works. And this kind of thing, some of you may be taking chemistry at some point in time. You're going to deal with logarithms in a chemistry class. That's very common to do that and work with these properties in a chemistry class. Okay, let's go to next page, just a couple of more things to do. Then we'll start working some examples out and kind of seeing how much of this we can begin to put together. This whole section is all about properties. Okay, so what this one says on this property 7, it basically says if you have a log of something to a power, this power can always come down in front of that logarithm. Again, what I'm going to do on this is just demonstrate this to you on a calculator, okay? All right, so let me give you a couple of examples to write down, and we'll do these on the calculator. Let's do log of 10 to the 3rd power, okay? According to this property, you can bring the 3 down and multiply it by the log of 10. Okay, let's do that on your calculator, and let's see if that works. See if this is enough to convince you. So you would type in like log of 10 raised to the 3rd, and you'll get a nice simple answer on that, 3. Okay, well, let's see if it works. If we go 3 times the log of 10, let's just see if that works. Well, okay, it does. All right, so that's what that problem's saying. Here's another example. ln of, let's say, 5 to the 7th power. Well, you can bring the 7 down and multiply it by ln of 5. Now, you're not going to get a nice simple answer on this problem. So if you put this in, you would go ln 5 raised to the 7th. You don't have to have that closing parenthesis. You would get 11.26. Well, if you did 7 times the natural log of 5, you'd get the same answer. Okay? All right, so simple properties of logarithms, the more of these things that you learn how to work with, the easier it's going to be for you. Okay? So what this property 8 says is really says this. It says you can take a log of both sides of an equation. Okay, when we solve equations, you're used to doing that anyway. So that's a worthwhile thing to write down. That's what, in words, what that property says. So there's going to be times when, and we're going to learn how to do this some this week, like if you had an exponential equation. I'm not going to solve this equation, but if you had the equation 2 to the x equals 3, I am going to show you this week how to solve that equation using logarithms. Well, what you can do is you can do a log of both sides. Okay, that's how you can basically do that. So if you have any equation, you can take a log of both sides, or you can remove a log. Okay, so if you had an equation like logarithm of, say, x plus 3 equals logarithm of 4, Well, what you can also do is you can take off the logs. You could just end up getting the equation x plus 3 equals 4. So all that statement is saying is it's okay to always take a log of both sides of any base, doesn't matter what the base is, or if you have just one log on both sides of the equation, you can take it off. And then you will see why we learn these things once we learn how to work with equations, and that'll be in the section 6.6. Okay, so that's kind of the idea. That's a summary. Now, what I'm going to do is we're going to work some problems out together. And mainly what we're trying to see on these problems is which property goes along with which problem. So this problem right here says ln of 1. I want you to look at the previous page. Which property tells you about doing a logarithm of 1? Property 2. So what's the answer if you do a log of 1? 0, exactly. So that one is going to be property 2, and that answer is equal to 0. All we're trying to learn on these problems is how to do the properties right now, okay? All right, the next problem says log base 3 of 3. Look at the previous thing and see if anything on here might help you to solve that one. You got to have the same structure. What do you think of property 3 maybe? Let's see if we can deal with property 3 on this problem. Okay. Here's what property 3 basically says. Property 3 says if you have a logarithm base 3, then the answer to that exponent is the answer to the problem. That's what that says basically. Okay. Now, last week I taught you all how to do these problems without even learning the properties, which is fine. You do not want to forget how to do that. If you go to this problem right here, the way I taught you how to do this last week, or a week before fall break, is I said, okay, just set it equal to x, like this. You still want to do this because the best way to learn all these things is to learn how to figure them out in your head. You set that equal to x. If I say write in exponential form, you say 3 to the x equals 3. So x has to be 1 because 3 to the 1 is equal to 3. Okay, so that's what that one would say. Okay. All right. Go to example 3. This one says log base 9 of 9 to the third. Now look at the previous page and see if you can match up which property would be helpful on this example. This one's a little easier to see than the last one. That's still property 3, right? And what property 3 says is the answer is that exponent, okay? So on this one, this is property 3. What's the answer? 3. Okay, like that, okay, automatically. If you have that structure, you've got that, okay? All right, example 4 is also easy to see, I think. Look at the previous page, and which property do you think would be helpful on this problem? What'd you say? 4, exactly. Property 4 would be helpful, and that just says, and what you're looking for on this example is the 2 and 2 have to match, so 10 is the answer based on property 4. Okay, that's how that one works out. Okay, okay, now we go to example 5. Well, okay, let's go to here. Okay, what do you think on example 5? I see a log plus a log. Which of those properties tells you anything about a log plus a log? Property 5 does, in reverse, exactly, okay? So what we're going to do on this is going to be property 5. And what property 5 says you can do is if you have a sum of 2 logs, you can put it together in one log and multiply the 9 times 4, okay, like that, okay? That's what I'm kind of showing you how to do on the calculator. So that would give you the log base 6 of 36. Now, we still want to figure this out. Now, my goal for you guys would be, can you figure this out in your head? All you're doing on a logarithm is you're always asking this question. What power of 6 is 36? What do you raise 6 to get 36? 2, exactly. The answer of problem is 2 because 6 to the second is 36. That's what a logarithm is it's an exponent, okay? So that's equal to 2 because 6 to the second equals 36. So that's how you get the answer to that problem, okay? All right, example 6 is the same property in reverse. Anytime you have a log of two things multiplied, you can write this as the logarithm of base 3 of 9 plus the logarithm base 3 of 27. That's what property 5 tells you that you can do. Now, I would love it if students are able to just, boom, be able to do this quickly in their head. What do you raise 3 to get 9? 2. What do you raise 3 to get 27? 3. So you've got 2 plus 3, right? Okay, you can do that in your head. If the logarithms are pretty simple, you can do it in your head. So that's going to be 2 because 3 to the second is 9. This one is going to be 3 because 3 to the third is 27. So you would just get an answer of 5 on that problem now. That's the idea. And you can't do that problem on your calculator. I don't want you to do these problems on the calculator. I want you to learn the properties and be able to reason these out. Okay, is there questions on those last two examples I did? Okay, all right. Once you kind of learn the properties, you can do a lot of these things pretty quickly. You really can. Okay, all right. Let's go to the next one right here. So example 7 says you have, this one is actually going to be more than one property. All right, the first property is property 5 again. So property 5 says, on the previous, on page 1, property 5 said, when you add two logarithms, you can put it into one logarithm of a product. So the first thing you would do on this problem is you would write this like this, okay? You would have 5 log base 5 of 6 plus log base 5 of 7 would tell you that you have 5 log base 5 of 6 times 7. Okay, anytime you add two logs, you can squeeze it into one log where you multiply. So that would be 5 log base 5 of 42. Okay, now I know the answer automatically. I don't know if you guys are to that point yet or not, but there was a property that told us what the answer to this was. You know? 42, right. We had the property that said this to this power. And those things have to match. The 5s have to match. 42 is your answer. That was property 4. Okay, so you're using both property 5 and property 4 here to get that answer. Okay, so that's how that one goes. Okay. Okay, next one. All right, well, there's more than one way to do these problems. This one, whenever you see a natural logarithm, ln, it's always good to write down that that really is log base e of e to the square root of 3 power. Okay, don't forget that ln, we don't ever write the base on ln. It's understood that it's e. All right, now look at the properties and see if you see anything that looks like this. The answer is automatic. The answer is staring you right in the face if you know the property. What do you think? What'd you say? Yeah, it is square root of 3. What was the property? Yeah, property 3. Property 3 said you have log base b of b to the x. That x is automatically the answer, right? Okay, so this would be property 3. The answer is square root of 3. Okay, all right, very good. Okay, so I'll give you a little bit of time to see what you can do just on these problems. Some of these are a little easier than the ones I just did. I want you to kind of look at your properties and see if you can do the answer. Really, the answer to every one of these problems is pretty automatic. Number 6, you really can't do anything with number 6 except something with that exponent of 2. But these are going to be pretty much automatic, I think. Okay? So just look at the properties and see if you can get these done okay. Kind of what we got here. Okay, so this one right here if you have the property on this one was property 3. Property 3 said if you had log base b of b to the x, the answer is x. So that means 10 is the answer. That's what that one said. Okay, this one was property 2. Property 2 said the log of any base of 1 is equal to 0. So that's what that was. This one's the same thing. This is property 2. And remember, this is really a log base 10 of 1, so it's the same thing, okay? This one right here was property 4, which says if you have this structure, 12 automatically is the answer. So property 4 said b raised to the log base b of x equals x. So that x is represented by 12 in that problem, okay? This one right here could be done more than one way, but a good way to look at this is really log base e of e to the 4th, and we had this property that said log base b of b to the x equals x. That was actually on that one property 3, so 4 is the answer to that one automatically, okay? And then the last one, we had this property number 7. Property 7 said if you have the log base b of x to the p power, something like that, that can come down in front. So really on this one, all you can do is just bring the 2 down in front, and you couldn't do the rest of the problem. You can't do the log base 5 of 6 because you don't know what power of 5 would give 6. I don't know. It'd be 1 point something. That's about the best I could do, okay? Okay, so I think we did okay with that. Any questions on that? Okay, next thing that we'd like to kind of go through is what we call the change of base formula. And change of base formula is real simple to do. You're going to see on your calculator, you only have a button for base 10, the log, and you have ln, that's a base e log. But you can do any other logarithm by the change of base formula. There's nothing to the change of base formula. It just basically goes like this. I'm just going to go over these examples like this and just show this. So let me just have you write down one example up here. Say that you wanted to do the log base 7 of 20. Okay, well, you got 2 ways you can do this. You can either go log of 20 divided by log of 7 and do that on the calculator. Okay, so I want to do that just on the calculator because you only have a log and an ln button. So you could go log 20. You have to use parentheses, got to close parentheses, and then divided by log of 7. Okay, and then you just estimate that. I'll just round that to like 1.5395, just round to whatever. You can also use the natural logarithm. You can do ln of 20 divided by ln of 7, okay? But you'll get the same answer. Okay, if you don't believe me, you can type that in your calculator. I mean, it doesn't matter which base you use, that ratio is always going to be the same, okay? So that you have to do that in the right order. So you do that ratio like that. That's what the change of base formula is telling you to do. So it allows you to do any logarithm, okay? So let's do just kind of these together. You can do it either way. Let's just use like an log on this first one. So this would be the same as log 20 over log 5. Okay, that's how you have to do that. Your calculator doesn't have a base 5. I mean, some of the more advanced ones can do that. I showed that a couple of weeks ago. But what you do is just do this on your calculator. We could do log 20, close parentheses, divided by log 5. And then let's round this off to just maybe 4 decimals or something. So that's 1.8614 if I rounded that off to 4 decimals, like that, okay? So you either use the log or the ln. It's your choice. I don't care what you do. This one, I could do log or I could do ln. This time I'm going to do ln of square root of 2 divided by ln of pi, and then I'll do that on the calculator, okay? Just a personal choice to use ln. So try it on your calculator if you want to. You have ln. You put in square root of 2. Make sure that you close the parentheses when you're done with that part. Then divide by ln pi. You have your pi key right below the clear button. So you can put that in like that. And then we'll just round that off to like 0.3028 like that. Okay. Okay, all right. So usually nothing to that. Everybody understand what I'm doing okay? Okay, so if I want you to use change of base formula, it's used to do any other base other than E and 10, like your calculator does. Okay, let's take a look at this one. This is just kind of an interesting problem to me, at least I think it is. I'll see what you think. Okay, what I'm going to do on this is I'm going to use change of base formula. The only way you can do log base 3 of 8 is to use the change of base formula. So let's just use log this time. Let's say we would have log of 8 divided by log of 3. That's how you would do that first part. Okay, the second part, we're going to do this. We would have log of 9 over log of 8. Okay, like that. So the idea with this is this thing right here, those things would cancel out. And then what you would have on that is you would just have log 9 over log 3. And then I'm just going to have you go to the calculator from here. I just wanted to show you that you could have a situation where you could have cancellation. You're going to get a simple answer on this problem too. Okay, so if you just put in log of 9, close parentheses, log of 3, that's going to give you 2. Does anybody have any thought about why it's 2? 3 to the second's 9. That's why. Yeah, that's why. Okay. All right. Okay. All right. So let's go. I think change of base shouldn't be that hard for you. The next thing, and what I want to work on mostly for the rest of the section, is using property 5, 6, and 7 to take a log and expand this. And these are things that if you're going to take more advanced math, you do a lot. I know in my calculus class, we do this from time to time. It becomes more and more important. These are things that, again, you'd see like in chemistry, you deal with logarithms when you work with pHs of acids and stuff like that. So if I say expand, notice that both of these examples have one log. That means I want you to write it so it has more than one log. So property 6 is what you're going to use on this. Property 6, we've already learned, says if you have a log of a fraction, you do the difference of the log. So you just write this as log base 4 of y minus log base 4 of 8. Okay, now be sure when you write these things, that's a subscript. A lot of times you've got to make sure that you're writing that so I can clearly see that's a subscript right there. And that's all you're going to do on that problem, okay? We're just learning how to expand these things out a little bit is all. Okay, not going to take that one any further, although we could. That's not the point of the problem. Okay, the next one is property 7. Property 7, we've already learned. We said that this exponent can be brought down and it becomes the coefficient of the log. So bring the 6 down. You would write that as 6 times the logarithm base 7 of x. Okay, that 7 is a base, so you end up with the log base 7 of x. And that's it. We're just learning how to use the properties to change the one log into more logs. You use this for solving equations. Okay, all right, they'll get a little harder. Okay, so let's take a look at this one. This one goes back again to property 5, and property number 5 goes like this. Okay, anytime you're doing a log of a product, you're going to have ln e to the negative x plus ln of y like that. So if you have a product, break it up in sum of 2 logs. There is one more thing you can do with this problem. What are your thoughts about the negative x? Can I do anything with that negative x? I can bring it down. That's what property 7 tells us to do. So yes, you want to bring those things down. Good. So you would end up having negative x times ln e plus ln y. Okay, now we're not going to take these things any further. You could do this on this, but I just want to show you that if you do the ln of e on a calculator, if you go ln of e you're going to get 1. So you could take this one step further and just write this as negative x times 1 plus ln y. So the simplified version of this would be negative x plus ln y. Okay, because ln of e is equal to 1 because e to the first power is 1. That's why that's the case. Okay, all right. So the next thing on this next problem, again, this is multiplication. So property 5, again, property 5 on this is going to tell us that we could write this as ln of x plus ln of square root of 1 plus x squared. There's going to be a little more we'll do with this problem, though. So the idea is we learned a little bit earlier in the semester, for example, like remember the square root of 16 is the same as 16 to the 1/2. You all remember that? Square root and the 1/2 power are exactly the same thing. So you could also write this as ln of x plus ln 1 plus x squared to the 1/2 power. Okay? There's one more thing I can do with the problem. What do you think? Yeah, I can bring that 1/2 down. Okay, don't forget to do that. So that property 7, that's what that property 7 above the page tells you can do. You can do that. So you want to take that a step further. So you would have ln x plus 1/2 ln 1 plus x, like that. Okay, then that would be as far as you can break that down. Okay, so we're just kind of learning how to use these properties of how you break up products and what you do with the exponents on logs. That's an activity that kind of builds up to equation solving we'll do in a few minutes here. Okay, let me do a couple of them that are a little bit more complicated. Okay, property, if you look at the properties, property 6 basically says you can break a fraction into a difference. Okay, so on what we're going to do on this one is we're going to use property number 6, which says we do the log of the numerator, and you need to have that x squared minus 1 in parentheses because you're doing the log of that whole thing, and then minus the log of cube root of x minus 2. Okay? Now, there's one other thing we can do. Any thoughts? Change it to a 1/3 power, right? Okay, so you want to change this. You want to write this as log x squared minus 1 minus log x minus 2 to the 1/3. Okay, then what can I do with the 1/3? Bring it down front. There you go. Good. Okay, so what we get is we get the log x squared minus 1 minus 1/3 log x minus 2, so we get that. Okay, that's as far as you can do that. There's nothing else you can do. Students a lot of times think that you can do this. Students a lot of times think that you can do log x minus log 2. There is no such property. You can't do that. So don't be tempted to do that. Okay, there is no such property. Okay, all right, here's how you do the next one. The first thing is anytime you have a log of something to a power, well, that 3 can be brought down in front. So you want to start the problem this way. So that would be 3 times log base 2, 2x minus 3 all over x plus 1. Okay? Now, there's one other thing I can do. Okay? What do I do with a log of a fraction? Subtract, exactly. So you got that property. Now you can write this as 3 times, and you would want to put this like in a bracket. You would say log base 2, 2x minus 3, minus log base 2 of x plus 1, like that. So that's as far as you can take that. Do not be tempted to think this would be log of 2x minus log of 3. That is totally wrong. There isn't such a property. Okay? We're only kind of using these 3 properties on these problems. If I say expand the logarithm, you're basically learning how to change the one logarithm into several by using these properties. Okay, I'm going to have you do these 4 problems at the bottom of the page. You don't have to tell me what the properties are. I want you to just expand these as far as you think you can expand it. Okay, using property 5, 6, and 7 that are on the previous page. So let's see how well we can do with these things, okay? D, okay, just to something a little different. And D, change that to ln, let's say, x squared over 4th root x to the 3rd plus 1. Do that instead, if you will. Okay, so just see if you got what I got. The first one, since you have a product, you write this as log base 6. And see, make sure you write that 6 as a subscript. Then that's x squared plus log base 6 y to the 4th. Then bring your exponents down in front. So you'll bring the 2 down. That'll give you 2 log base 6 of x plus, and then bring the 4 down. That would be 4 log base 6 of y. So that's how your answer goes on that. I think everybody got that okay. I gave a little bit of help on that. So that's the idea. The next one, since it's a fraction, you write this as a difference of 2 logs. Now that a to the 4th, this is a log base 10, by the way. You don't have to put base 10 there, but I noticed some of you were writing the a like it was a subscript. That's not the case. You don't have to put the 10 there, but the base is 10. Then you would have minus log b to the 2nd, and then all you can do is bring those exponents down in front. So you would get 2 log of a, and a is not a subscript, minus 2 log b. That's it. That's as far as you're going to take that. That's the whole point of the problem. Okay? All right. Next one was a little harder for you, I thought, but it is a fraction. So you start off by saying ln e to the negative x times y minus ln of z to the 5th. Okay? It's a fraction. So you write it as a difference of 2 logs. Then this part right here can be broken up in a sum. So you would say ln e to the negative x plus ln y minus ln z to the 5th, like that. Okay? Now you can bring these exponents down. The negative x comes down in front. So that would be negative x times ln e plus ln y minus 5 times ln z. If you got that answer on your paper, I'm okay with that. But anytime you see ln of e really means log base e of e. That's equal to 1. The reason it's equal to 1 is because e to the 1st is equal to e. So it would be good to just change that to 1 and get the answer negative x plus ln y minus 5 ln z. So if you didn't do that ln e, you need to go ahead and do that now and just finish that up, because that's something that pops up quite a bit. ln of e is equal to 1. Okay, next one. Hey, it's a fraction, so it's a difference of log. So you'd say ln of x squared minus ln, and I'm going to go ahead and write this as x to the 3rd plus 1 to the 1/4 power. Okay, now what you can do is the exponents come down in front, and as far as you can take this problem, is just write this as 2 times ln x minus 1/4 ln x to the 3rd plus 1. You cannot take that one any further. Do not break this up into ln x to the 3rd plus ln 1. That is totally wrong. Okay, I see students do that constantly. There is no such property. Okay, all right, any questions? Okay, just trying to get the exercise we're trying to do here is just trying to get you to learn how to do properties before we do any application, which we'll do in 6.6, second part of class. Yeah. Which one? Part B? Oh, why did I do that? I don't know why I did that. That should be a 4. I even put the arrow. So anyway, thank you for pointing that out. That's the correct answer now. Okay. All right. So yeah, part B was 4 log A minus 2 log B. All right. Very good. Let's go ahead and take a 10-minute break. And I think we got some progress down on this. This is the opposite of this. These problems I've given you more than 1 log. and you're working it backwards. You're going to put it into one log. So you're going to write this as one log. So you have to do this in a certain order. So one of the things that you learn is if there's a number in front of a log, this thing can become an exponent. So this problem, the first thing that you want to do is you want to do that property in reverse. You guys were taking the number down, the exponent come down in front. Well, you can do the opposite of it. So step one, you would have log base A of x to the second plus log base A, make sure you write the A as a subscript, that's the base, of y to the 1/4. Okay, now that's a plus sign. So if it's a plus sign, are we going to say log of x squared times y to the 4th, or are we going to say log base A of x squared over y to the 1/4? Which is it? Times, exactly. Okay, so this one, anytime you have a plus sign, that tells you that now when you put this into one log, you write that as x squared times y to the 1/4. And now you're done with the problem, because the goal of this problem is to have this into one logarithm, and you don't want to have anything in front of that logarithm. Okay, nothing needs to be in front of that log. You're just working totally backwards of what we did a little earlier in class before we took a break. Okay, all right, next problem. Always look for this. If there's something in front of the log, make that an exponent. You have to start that way. You have to do these things in a certain order. So this would be log x squared plus 3x plus 2 minus log of x plus 1 to the second power, like that. Guys, you have to start it that way. Okay. Now, what do I do on this one? If I put this in one log, am I going to multiply those two things, or am I going to make it into a fraction? Fraction, right, good. Okay, so we're going to say log, don't worry about the base, that's base 10, x squared plus 3x plus 2 over x plus 1 to the second, like that. Okay, that's how that gets put together. Now, algebraically in this problem, it turns out that there is something you can do on this problem. This part right here can be factored. So I'm going to go to the side of the paper and just kind of factor this right here. You want to go ahead and get that factored, okay? So this one, you're going to have x and x. What are you going to use for 2? 1 times 2, right? So you're going to have 1 times 2. And you want the 1x and the 2x, you want that to add up to 3x, so you need to have plus plus. Okay, so you do need to go ahead and factor that. So now you would end up having the logarithm of x plus 1 times x plus 2. Now I'm going to write this. You don't have to do this because you can do this in your head, but that denominator is x plus 1 to the second. So what I'm going to do is I'm just going to write it out twice. Okay, what do you see happening, if anything? That cancels, right? That's the reason I did that. Good. Okay, so one of them cancels. So your final answer would actually be the logarithm of x plus 2 over x plus 1. Okay, and you're doing the log of that entire expression. So again, the idea is we're trying to write this so it's into one log. Okay, we use this for equation solving. If you take calculus, you use it for derivatives and integrals and all kinds of things. It's a basic algebraic skill. Okay, all right. All right, let me do one more. Let's see what we can do on this. Okay, so what is your suggestion about how I start this problem? Bring the numbers in front. Okay, that's the first thing I always look for. Those things, the numbers in front of the log become your exponent. So that's going to be log x to the third plus 1 to the 1/3 power plus the logarithm of x squared plus 1 to the 1/2 power, like that. Okay? Now, when you put this in one log, are you going to multiply those two things, or are you going to make a fraction? Multiply. How do you know? Plus sign tells you that, right? So you write this as logarithm x to the third plus 1 to the 1/3 times x squared plus 1 to the 1/2, and that's it. Once you get the log together into one logarithm, right? The goal is one log, then that's as far as you're ever going to take these. Okay, so that's the idea. Okay. All right, do we have a question? Good, bad, indifferent? Okay, all right, thank you. All right. All right, let's try to do just these two at the bottom, and then that's it. That'll be the end of that section, and then we'll. Okay, so let's take a look and just make sure that you're doing all this okay. First step always is to look for the number in front of the log and bring those up. So you should have started by having log base 2 x to the third plus log base 2 x minus 5 to the fourth. Okay, since it's a sum, when you put it together in one log, you write the product of x to the third times x minus 5 to the fourth. So it's totally backwards of what we were doing. You know, early in the class, I gave you this problem, and you took it to the top like that. You just did everything backwards. Okay, so you have to kind of learn how to do things forwards and backwards. Okay, this one you should have started by bringing the 2 up. So you'd have the log of x squared minus 4 minus the log of x plus 2 to the second. Now, this is a subtraction symbol, so you want to put this together as a fraction, x squared minus 4, x plus 2 squared like that. And if something factors, you want to factor it. So the factoring of x squared minus 4 is the difference of two squares. That one factors as x plus 2, x minus 2. That's how the numerator factors. And then I'm just going to write out the x plus 2 to the second twice. And then notice that you have that cancellation like that. So your answer on this problem is going to be log x minus 2 over x plus 2 like that. Okay, so that would be the process you go through to solve.